Hello and welcome to Education at SSBJ online video tutorials. As usual, we shall take up a question, and this time the question is prove first equation of uniformly accelerated motion graphically. As how in all the previous videos we start with a question and then try to learn different aspects of chapter motion of class 9th. Here also we shall try to understand the answer as well as the concept related to this question. Now please observe this question. Prove first equation of uniformly accelerated motion. Right. What does uniformly accelerated motion mean? Now let us have a journey of a car. A diagram goes this way. On above the line I am mentioning a velocity. Please remember velocity, not the speed. Velocity comes with the direction. Since it's a straight line motion, we can take this either a velocity or speed, but here I am emphasizing on velocity because we are talking about acceleration, and the down below I am writing a time. So what does this line indicate? That for the first second its velocity was 2 meter per second, and then it goes on increasing, you can see. And if you can convert the entire journey into tabular column, you can see here first second 2 meter per second, second 3 meter per second, third second 4 meter per second, fourth second 5 meter per second, and so on. It is written this way. Now suppose if I can take this entire to one corner and try to plot this graph, right? You already learned how to plot the graph. We have to plot the graph velocity against time. So the y-axis represents velocity and x-axis represents time. So please refer the previous videos. We have discussed in detail about the different graphs. Now here, as far as this graph is concerned, okay, we can immediately go for plotting the graph here. First second we have got 2 meter per second here. For the second 3 meter per second. For the third second 4 meter per second, and so on. Right? And now we can complete the graph. A graph is a straight line. And why is it straight line? Because the change in velocity here is in equal amount. Okay, so I am again reminding you, if velocity changes in equal amount, then the acceleration of the body is referred as accelerated motion, uniformly accelerated motion. Let me correct. It is called uniformly accelerated motion. If suppose velocity increases but not in equal amount, then it is simply an accelerated motion. Now why it is uniformly accelerated motion? Because between every second here, okay, every 2 intervals of time, how much is the increase in velocity? 1 meter per second. That's why 2 meter per second became 3 meter per second, and so on. Okay, and that is why it is called uniformly accelerated motion. So please keep this in the mind. Okay, so this word is very important, uniformly accelerated motion. Now we have learnt about a concept called slope. And what do you mean by slope of a graph? It's very simple. Slope is y-axis divided by x-axis. You can write y by x. Now what actually is a y-axis and x-axis? Now y-axis represents change in velocity. Look at this y-axis. What is there in y-axis? Velocity. Right? So it is actually y-axis is change in velocity divided by x-axis is what is changing here? Change in time. Right? And we already studied that change in velocity divided by time will be nothing but an acceleration. So acceleration is change in velocity per unit time or rate of change of velocity. Now as far as this graph is concerned, we shall try to find the slope of this graph. Okay, and how can you find the slope of the graph? You can fix a triangle. I'll take this as one point and this is another point, and so this will be one more point. I'll draw the line here and make a triangle, rectangle triangle, right? So what does this line represent? This is parallel to time axis. Look at this. So this is representing time. And what about this particular line represents? This is parallel to velocity. So this is representing velocity. Right? So let us write here A, B and C. Right? And now slight extension, what you do is this distance from here to here. If I can draw a dotted line here, this much of a distance is initial velocity. And why is it initial velocity? Anything you draw parallel to this line is a velocity. Now from here to here, how much is that? 2 meter per second. Correct? And what is that 2 meter per second? Vehicle has started from 2 meter per second. We have taken a graph from here to here, not from here. Okay, so this becomes our initial velocity. And what is final velocity? 7 meter per second is final velocity. Please remember this. So here this much of distance is initial velocity, whereas from here to here this much of distance is a final velocity, because this represents the entire y-axis here. This represents only this particular part. So please try to understand what is the initial velocity and what is the time. Or let me bring this line here. So this is the extension here. I am bringing it. Okay, and let me write, give a symbol here or a letter D. Right? So if this is the right angle triangle, I can write slope is equal to y by x, that is change in velocity by time, which is nothing but acceleration. Right? Now consider a body moving with the initial velocity. And what is the initial velocity we have to consider? Let us consider as u, and final velocity v. So let us not bother about these numbers now. Whatever may be the number, we'll take u as initial velocity, v as final velocity, and let us take time as t. Right? And now look at the graph. Okay, now look at the graph. That in graph, what does dB stands for? dB stands for initial velocity. And what is that initial velocity? Initial velocity is u. It is nothing but u. What does dA from from here to here stands for? As I have already discussed, that from here to here it is final velocity. Right? So dA is equal to final velocity, which is small v. Right? This is small u. So please be familiar with these letters. We are using small u for initial velocity, small v for final velocity, and small t for the time taken, and a is the acceleration. Now what does AB? Okay, AB represents then. AB represents the distance This is a final velocity from here to here minus initial velocity. Please try to understand. From here to here final velocity, out of that if you take this much out, what left is AB. So if a final velocity is V and initial velocity is U, what is this length then? V minus U, right? So AB will be equal to dA, right? dA minus, this is dA, right? AB will be equal to dA minus dB, which we have already discussed, that is final velocity minus initial velocity. And what is final velocity? Final velocity is V minus U, right? So we can write V minus U. So we can write this length as V minus U. And what about this? This is initial velocity, that is U. And what about the distance from here to here? Okay, that is, please recall, that is V. So now you can immediately understand now, since this is U and this is V, this will be V minus U, right? So we'll go ahead now. Now another, suppose if you can extend a line here, okay, now, and give one letter here, let us take E. This point is called E. What does ED represents? ED represents time, simple. Okay, now ED is nothing but CB. CB also time because it's parallel. So whatever is here is same for here. Whatever is here is same for here to here, right? Whatever is here is same for here, okay, because these are different representation of same y and x axis, right? Now since ED is representing t, okay, now our main equation comes here. By definition, what is acceleration? Acceleration is nothing but the slope. Slope of what? Velocity time graph. Okay, so by definition we can write slope of velocity versus time graph is nothing but acceleration. This is very important step, right? And what is that? You have to write slope is equal to y by x. And what is y? AB divided by x. What is x? X is BC. So you can see AB divided by BC is the slope of this graph, right? And what does AB equal to? AB is equal to V minus U, isn't it? AB, or you can even, you write AB divided by BC is nothing but ED. BC is nothing but ED. Now you can substitute here, right? Acceleration is AB by ED, right? Why acceleration is AB by ED? Because it's the slope of this graph, y by x. And then what is AB then? What is AB? Right, AB we have already done here. It's V minus U. And what is ED? ED is T. When you cross multiply, you get A into T is equal to V minus U. So if I'll do a rough work here, if AT is equal to V minus U, so AT plus this one you bring it this side, AT plus U is equal to V, and therefore V is equal to U plus AT. Simple algebraic expressions. V is equal to U plus AT. In the same way we can write here V is equal to U plus AT, which is the first equation of uniformly accelerated motion. So this is very important equations. And what is that equation? v is equal to u plus at, which means final velocity can be given by initial velocity plus product of acceleration and time. And how to prove that? This is the way you have to prove. This question is of 3 to 4 mark. You have to draw the graph properly and write all the steps which are there. Please go through the video. In case if you have any doubt, you can comment or directly ask me. Next, when you are asked to draw or prove on paper, you need not write all these journey and other things and all. You can simply put up your answer in this format. Even these numbers also you need not write. So what I am doing is I'll simply make x-axis as time and y-axis as velocity, right? And rest all you can keep here. This can be your final diagram. You can start with this diagram and start first with what is u, what is v, what is t and what is a. This is very important step. You cannot miss this step, because when you are using u, v, t and a here, you cannot simply start without explaining what are these things. So this will carry mark. Now next, what does different sides here represents, that will carry mark. Now this is important step. How will you arrive with the proof? This, without this step you cannot. By definition, we should understand the slope of velocity time graph is acceleration. So y by x, the first you should fix that in the mind. To prove this equation, you should start with this equation. To start with this equation, you have to mention all these sides of this graph. That means you have to draw the graph. When you draw the graph, you have to mention what is u, v, t and a. All these steps are very important. Rest all are simple calculations. So final is v is equal to u plus at is the first equation of uniformly accelerated motion. We are going to solve as many problems on this. This is very important equation. We are going to get second equation and third equation in the same way. We shall study. This is the proof of this equation using graph. There are other ways of proving this, but for class 9 you will be asked to prove this using graph, right? Thank you very much.